Have you ever looked up at the night sky and wondered, where is all this going? I mean, we hear all the time that the universe is expanding. Galaxies are flying away from each other. Space is stretching. But here's the thing that always bugged me. If the universe is expanding, what exactly is it expanding into? Is there some giant empty void out there waiting for us? Are we like a balloon, inflating inside a bigger room? That's the question we're diving into today. And honestly, it's one of those mind-bending ideas that sounds simple, but messes with your brain in the best way. So stick around, because by the end of this, you might not just get an answer, you might see reality a little differently. Let's start with what we actually know. Back in the 1920s, an astronomer named Edwin Hubble made a discovery that changed everything. He noticed that distant galaxies weren't just sitting still, they were moving away from us. And not only that, the farther away a galaxy was, the faster it seemed to be speeding off. That was wild. It was like if you threw a ball and the ones that landed farther actually flew faster. At first, people thought maybe we were at the center of some cosmic explosion. But that didn't make sense. Turns out, it wasn't that galaxies were moving through space. It was that the space between them was stretching. Imagine drawing dots on a rubber band. When you pull the rubber band, the dots move apart, not because they're crawling away, but because the band itself is stretching. That's kind of what's happening with the universe. Space itself is expanding, carrying galaxies along with it. But here's where it gets tricky. When we say the universe is expanding, most of us picture something like a balloon inflating. You blow air into it, the surface stretches, and the dots on it move apart. That's a great analogy for helping us visualize expansion. But, and this is a big but, the balloon is expanding into the air around it. So naturally, we think the universe must be expanding into something too, right? Well, not necessarily. And this is where things get weird. See, in the balloon analogy, the surface of the balloon is like our 3D universe. But the third dimension, the one where the balloon is inflating into, isn't part of that surface. It's kind of like an extra direction we can't experience. So when we ask what the universe is expanding into, we might be asking the wrong question. Because maybe there is no into. Maybe the universe isn't expanding into anything. It's just getting bigger, all on its own. Let me try to explain that a different way. Imagine you're an ant living on the surface of that balloon. You can only move forward, backward, left, and right. You have no concept of up or down. To you, the entire universe is that 2D surface. Now, when the balloon inflates, all the other ants move farther away from you. The space between you stretches, but you don't see any edge. You don't see a direction where things stop. If you walk in a straight line, you might eventually come back to where you started, just like how you can walk around the Earth and end up where you began. From the ant's point of view, the universe is finite but unbounded. No edges, no center, just endless surface. And that's kind of how our universe might work. We're like 3D ants on a 4D balloon we can't see. The expansion isn't happening in anything we can point to. It's just the fabric of space stretching in all directions. Now, I know what you're thinking. But if space is stretching, doesn't there have to be something outside for it to stretch into? That's a totally fair question. And it comes from how we experience the world every day. Everything we see expanding, like a balloon, or dough rising, or even your jeans after Thanksgiving dinner, expands into some surrounding space. But the universe isn't in space. The universe isn't in space. The universe is space, and time, and everything in it. So there's no outside, in the way we usually think. Asking what the universe is expanding into might be like asking what's north of the North Pole. It's a direction that doesn't exist. There's no beyond the universe, at least not in any way we can measure or observe. The universe isn't expanding into anything, it's just expanding. But wait, what if the universe does have an edge? What if there's a boundary somewhere? That's a possibility some scientists have explored. But here's the problem: we've never seen any edge. In every direction we look, as far as our telescopes can see, over 13 billion light years, we find more galaxies, more stars, more space. And it all looks pretty much the same. No walls, no borders. No signs that say end of universe. If there were an edge, we'd probably see some kind of asymmetry, like one side having more galaxies or different physics. But we don't. The universe appears to be homogeneous and isotropic, which is a fancy way of saying it looks the same in all directions and from every location, at least on the largest scales. That suggests there's no center and no edge. Just endless stretching space. And here's another wild idea. The universe might be finite in size, but still have no edge. That sounds impossible, right? How can something be finite but endless? But think about the Earth again. The surface of our planet is finite. You could wrap a giant ribbon around it and measure it, but it has no edge. If you walk in one direction long enough, you come back to where you started. The same could be true for the universe. It might be shaped like a 3D version of a sphere, what scientists call a closed geometry. In that case, if you could travel in a perfectly straight line for long enough, ignoring expansion for a second, you might eventually return to your starting point. But we don't know for sure. The shape of the universe is still a mystery. Observations from the cosmic microwave background, the leftover glow from the Big Bang, suggest the universe is flat or very close to it, and a flat universe could be infinite. Which means it goes on forever and has always been infinite, even at the moment of the Big Bang. Wait, hold on. If the universe is infinite, how can it expand? Doesn't expanding mean getting bigger? How do you make infinity bigger? That's a great question. And the answer is, expansion doesn't mean the universe is growing into new space. It means the space within the universe is stretching. So even if the universe is infinite, the distance between galaxies increases over time. Think of an infinite grid. If you stretch that grid so that every line gets longer, the grid is still infinite, but everything on it is now farther apart. So expansion isn't about the universe growing into emptiness. It's about the scale of space itself changing. Galaxies aren't flying apart like shrapnel. They're more like raisins in a loaf of rising bread. The dough, the space is expanding, and the raisins are just along for the ride. Now, let's talk about the Big Bang. A lot of people picture it as an explosion in space, like a giant fireball going off, sending matter flying in all directions. But that's not quite right. The Big Bang wasn't an explosion in space. It was the rapid expansion of space. And it didn't happen in one place. It happened everywhere. The entire universe, every point in space, was incredibly hot and dense, and then it started expanding. So there's no center of the Big Bang. Every location you see in the universe today was part of that initial hot, dense state. It's like baking a cake. The whole thing rises at once. There's no center of rising. Every bit of the batter expands. That's why, no matter where you are in the universe, it looks like galaxies are moving away from you. You're not in a special spot. It just looks that way because space is stretching everywhere. So, Going back to our original question, what is the universe expanding into? The honest answer is, we don't know. And more importantly, it might not be a meaningful question. In the same way that a 2D ant on a balloon doesn't need to know about the third dimension to understand that the surface is stretching, we might not need an outside to explain cosmic expansion. The math of general relativity, Einstein's theory of gravity, describes how space can expand without requiring anything beyond it. The equations work perfectly well with a universe that's self-contained. No edges, no container, just space, time, matter, and energy, all playing by the rules. But I know that's hard to accept. Our brains are wired to think in terms of containers. Everything we've ever seen has an outside. So it feels unnatural to imagine something that doesn't. But the universe doesn't care about what feels natural to us. It does what it does, whether we can picture it or not. And sometimes the truth is stranger than any analogy we can come up with. Let's take a step back for a second. How do we even know the universe is expanding? It's not just theory. We have real evidence. One of the biggest clues comes from something called redshift. When light from distant galaxies reaches us, its color is shifted toward the red end of the spectrum. That's because the space the light traveled through has stretched, which stretches the light waves too. Longer wavelengths mean redder light. The farther away a galaxy is, the more its light is redshifted. Exactly what you'd expect if space is expanding. This isn't just a one-time observation. We've measured redshifts in thousands of galaxies, and the pattern holds. The universe really is stretching. Another piece of evidence comes from the cosmic microwave background, or CMB. This is the oldest light in the universe, radiation left over from when the universe was just 380,000 years old. It's like a baby picture of the cosmos, and it's almost perfectly uniform in temperature, about 270 degrees Celsius, just a hair above absolute zero. But there are tiny variations, tiny ripples in that glow. Those ripples match predictions from models of an expanding universe. They also tell us about the geometry of space. As I mentioned earlier, the data suggests the universe is flat, or so close to flat that we can't tell the difference. And a flat universe could be infinite, which means, again, no outside to expand into. Now, here's where it gets even more mind-blowing. The expansion of the universe isn't slowing down, it's speeding up. In the late 1990s, astronomers studying distant supernovae discovered that the expansion is accelerating. That was shocking. Gravity should be pulling everything together, slowing the expansion over time. But instead, something is pushing space apart faster and faster. We call that something dark energy. We don't really know what it is. It doesn't emit light. It doesn't interact with matter the way normal stuff does. But it makes up about 68% of the total energy in the universe. And it's the reason why, billions of years from now, distant galaxies will disappear from view. Not because they're moving too fast, but because the space between us and them will be expanding so fast that light can't cross it. Eventually, we'll be alone in our little cosmic neighborhood, with no sign that the rest of the universe ever existed. So, what does dark energy tell us about the into question? Well, not much directly. But it does show that the universe has properties we don't fully understand. Expansion isn't just a leftover effect from the Big Bang. It's being driven by something mysterious that's built into the fabric of space itself. Some theories suggest dark energy could be a property of the vacuum, the energy of empty space. Even nothing, might have energy, and that energy could be causing space to push itself apart. If that's true, then expansion isn't about the universe growing into emptiness. It's about emptiness itself having a kind of pressure that stretches space from within. Now, I want to address a common misconception. A lot of people think the Big Bang happened at a single point in space, like a tiny dot that exploded. But again, that's not accurate. The Big Bang happened everywhere. The entire observable universe, everything we can see, was once compressed into an extremely hot, dense state. But that doesn't mean it was a small object in a larger space. It means that space itself was smaller and denser. There was no around it, no empty room it was in. The universe wasn't a firecracker in a dark sky. It was the sky, and the ground, and everything. So when we look at distant galaxies, we're not seeing the edge of the explosion. We're seeing the edge of the observable universe, the farthest light that's had time to reach us since the Big Bang, about 13.8 billion years ago. But that doesn't mean the universe ends there. It probably goes on much farther, possibly infinitely. We just can't see it because light from those regions hasn't reached us yet, and due to expansion, it never will. That's why we talk about the observable universe as a bubble around us, about 93 billion light-years in diameter. But the whole universe, that could be vastly larger, or infinite. We just don't know. At this point, you might be wondering, could there be other universes? Like, is our universe just one bubble in a bigger multiverse? That's a popular idea in some theories, like eternal inflation. The idea is that space is constantly giving birth to new pocket universes, each with its own laws of physics. In that case, you could say our universe is expanding into a larger multiverse space. But here's the catch. We have no evidence for that. It's still speculative. And even if it's true, the multiverse wouldn't be a place in the normal sense. It wouldn't be empty space waiting to be filled. It would be a different kind of reality, possibly with different dimensions and rules. So the question, what is the universe expanding into, still doesn't have a simple answer, even in a multiverse scenario. So where does that leave us? Let's recap. The universe is expanding, meaning the space between galaxies is stretching. This isn't expansion into something, it's expansion of a space itself. There may be no outside, no edge, no container, just an endless, stretching reality. The balloon analogy helps, but it's limited. We're not on the surface of a balloon floating in a room. We're in a 3D space that's part of a larger space-time fabric, and that fabric is evolving. Asking what it's expanding into might be like asking what the number 5 is made of. It's a question that assumes a framework that might not apply. And honestly, that's okay. Not every question has to have a neat answer. Some mysteries are meant to stretch our minds, not just our space. The fact that we can even ask this question, that we've built telescopes, written equations, and imagined realities beyond our senses, is incredible. We're tiny creatures on a small planet trying to understand the nature of everything. And we've come pretty far. So what should you take away from this? First, the universe isn't expanding into anything we can point to. It's just expanding. Second, that doesn't make it any less real or any less amazing. And third, it's okay to sit with the uncertainty. Some of the deepest truths in science aren't about having all the answers. They're about learning to ask better questions. If this video made you pause and look at the sky a little differently, I'm glad. That's what this channel is about, taking big, confusing ideas and breaking them down so they make sense without losing the wonder. If you enjoyed this, please consider subscribing. It helps more people find these videos and keeps the curiosity alive. And hit that like button if your brain feels a little bigger after this. I know mine does. Got a question about space, time, or reality? Drop it in the comments. I read everyone, and who knows, your question might be the next video. Until then, keep wondering. Keep asking. And remember, the universe might not be expanding into anything but your mind. That can always expand a little more.